Now we will talk about the Pythagorean identities. These identities, there are 3 of them and variations on the 3. So they are all derived from our knowledge of the unit circle. So we know within the unit circle, here's our unit circle, or unit ellipse, no, unit circle, we can construct right triangles. Our unit circle has a radius of 1. And then along the x, that is cosine of theta. Along the y is sine of theta. So I can use the Pythagorean theorem to actually write my first Pythagorean identity. So remember, our 2 side lengths squared, the sum of the side lengths squared equals the hypotenuse squared. So sine squared plus cosine squared equals 1 squared. That's the Pythagorean theorem. I can simplify that to be simply sine squared theta plus cosine squared theta equals 1. Okay, so one thing I do want to note, sine squared theta is equivalent to sine of theta squared. And that's important because our identities, they don't involve squared angles, so squared values. So it's important to know this. All right, so from this identity, we can derive 2 more. I am going to derive the first one, and for your example, you'll have to derive the second. All right, so I've got my identity here. So we have, call it example 4, derive other Pythagorean identities. All right, so I have sine squared theta plus cosine squared theta equals 1. All right, so I am going to start this. It's an equation, so I can, as long as I perform one operation on both sides of the equal sign, our equation remains equivalent. So I'm going to divide everything by sine squared theta. Okay, I'm still going to be using some identities here, so I'm going to make my box. So I've got sine squared, so let's simplify. So the first part of the expression, sine squared theta over sine squared theta, that's just equal to 1. All right, here in the middle, I've got cosine squared over sine squared, and I'm going to rewrite that such that I can use one of my identities to rewrite this. So I can write this as cosine theta over sine theta squared, okay? And this is all equal to 1 over sine squared theta, which I'm also going to write so I can use one of my identities. I'm going to rewrite this as 1 over sine of theta squared, okay? So now I can use some of my identities. So I've got a cosine over sine. So cos over sine, that is just cotangent of theta. All right, and then the other part, I have 1 over sine theta, which I know is cosecant of theta. Okay, now I can continue. So 1 is just 1. Plus, so cosine over sine is cotangent theta squared. All right, and that's equal to cosecant of theta squared. Okay, so now I can move those squareds on the inside to keep our notation correct. So cotangent squared theta equals cosecant squared theta. And there's our second identity. So you guys derived the third.